video series is funded in part by our kind backers on Patreon. Join today from just $3 per month and gain access to exclusive video and project-related downloadable content. Visit patreon.com/Wi-Fi Sheep. Links are in the description to this video.
Hello, how you doing? And welcome back to Electronics 010, the brand new electronics build series from youtube.com/Wi-Fi Sheep with me, Tom. Now, this video wasn't intended to happen. It certainly wasn't planned, but many of you got in touch with me after our first part 1 video asking me about the card setup for our custom cartridge. Now, if you're not up to speed on what I'm talking about, Electronics 010 is a brand new spin-off series of our Tiny Basic Computers series we've been running here on the channel, in which I'm going through the processes and showing you how to make a real electronics product from complete scratch. Last time we started with a breadboard and we built it up into this working cartridge for the Raspberry Pi 400. This cartridge allows you to mechanically switch ROMs, as well as having a backup battery on board for keeping the time if you're away from a Wi-Fi or cabled network connection. Now, I have to stress again, this series is about the process of designing and building an electronics device. It's not a tutorial on how to actually build this particular device. We're just using this as the example basis because it's a third-party private commission I've had for a commercial company. However, as I said, many of you got in touch with me asking for more details of how we actually set this up on the Raspberry Pi side to actually work. Now, I was hesitant about showing you this because it's not really part of the project, and also my setup for this is at the moment a little bit sketchy, to say the least. So I'm going to show you it in this video, but bearing in mind it's very much a beta quality example. I'm not going to be offering technical support for this, and it sort of works, sort of doesn't work, but I'll show you anyway and see what you think. But first, it's that festive time of year once more, and the fantastic PCBgogo year-end sale is now on. All PCBgogo customers, new or returning, can take advantage of a $50 off coupon when ordering your high-quality, professionally manufactured custom PCBs. And in addition, FR4 and aluminium PCBs are now 10% off, with an amazing 30% off Flex and Rigid Flex PCBs. So don't miss out on the PCBgogo year-end sale. Sign up for your free account today at PCBgogo.com. See the video description for full details and direct links to these amazing offers. So, you've already seen this. What you haven't seen yet, and this is a sneak peek, is this is actually a production board. So, prototype and the production board. And this uses the custom PCBs, which we're going to be designing in part 2, which is coming up. These are from PCBgogo.com. And yeah, no, nice little board actually. So I do have one that works and actually now fully works and is made up. So the question's about, do you need any setup? So for the clock itself, if you're running RISC-OS or RISC-OS Direct on the Raspberry Pi, then no, you don't actually need any kind of custom setup. It's automatic. If you want to use battery backup on Linux, that includes the Raspberry Pi OS, then I do believe you do need to do manual setup. Plenty of links on how to do that if you search online. The next question was about the actual ROM switching function of being able to go from A to B backing, which I demoed in the video. And people asking me about the setup. So for that to work, and I will show you the setup, you need a working Raspberry Pi Linux image. The label on that's got a bit roughed up, but basically that's my Raspberry Pi OS. And you'll also need a RISC-OS, and this is RISC-OS Direct on this card. So we're actually going to use this card as the base. We're going to build our switchable OS on top of Linux, but we need some files, including the ROM, from a working RISC-OS or RISC-OS Direct SD card. So we'll start by taking this card and we'll go over to a Mac, and we need to rip some files. Okay, so I'm here just on a standard Mac desktop. You don't have to use Mac. This will work fine on Linuxes or Windows. That's not really a problem, but we're just going to use a Mac for the sake of it. So we'll create a new folder just on the desktop, and we'll call that RISC-OS. I've now got a RISC-OS Direct SD card, and I'm just going to put that in an adapter and into the Mac, and it comes up as a boot directory here, and inside you'll see a number of files. I'm going to open my new RISC-OS folder, and what we're going to do is we're going to put a number of files, copy them off this SD card, just load them onto the hard drive. So the files we need are command line, CMOS, RISC-OS image, and config.txt. Okay, and that's all we need. So we can eject this SD card. So now I've got a fresh Raspberry Pi OS Debian Linux, again on micro SD card, and we're going to mount that. And what we need to do here is rename command line riscos.txt. The CMOS you can leave as is. We will have two command line files, so we need to rename one to identify which file it's for. Config.txt we're not going to use, but we will come back to that. So all we have to do now is basically, without copying config, the other three files we can do a copy, and we can copy straight across to the boot directory where we can dump them on there. So I've just opened the config file. What you might want to do, like I did here, is I actually copied config, and I had a file called config old. It won't be read, but just in case I messed the settings up. But this is the config file for a dual boot system. So it's pretty much the standard Raspberry Pi, Raspbian Linux, or Raspberry Pi OS build. But we start here with a new line, which is GPIO setup, and we're calling GPIO equals 12, so that's pin 12, equals, and it's IP, comma, PU. Just to zoom in so you can see that. So PU is for pull up. So we're actually artificially in software pulling GPIO pin 12 high on boot. The rest of the settings are then pretty much standard. And we have a special one here for the Pi 4, but that's standard. Here I have added two files required for RISC-OS. These have been copied over from RISC-OS's config.txt file. And then the rest of RISC-OS's config.txt file, including which kernel to point at, is put into this area, which we start with these open square brackets of GPIO 12 equals 0, which is if it's pulled low. Remember, it's been pulled high. If it's pulled low, then we're going to switch command line. So the command line will now be command line riscos.txt, not command line.txt. And we'll also then set up these various settings here in order to make RISC-OS work correctly, including booting the riscos.image kernel. Once we're finished with these specific settings, we can return to anything left that we want to set generically using the all bracket text here. So that's fundamentally how this works. So it is possible you can set GPIO pin states in the config file, which is almost like the boot BIOS for a Raspberry Pi, before any operating system has actually loaded. So this is done at hardware or firmware level, not OS level. Okay, so we've got our SD card made up, and we'll just pop that into the Pi 400, and now we'll fit our cartridge, which goes in like that. Now, when booting this up, it will detect the switch on or off, or A and B, whilst powered down. So you can set the switch, power up the machine, and then whichever way it's set, it'll boot. While the OS is actually running, you can flick the switch, it won't make any difference, and it's when you power cycle the machine again, it will then on a reboot detect where the switch is and if it's pulling A or B low, and then it'll make the switch to boot the OS accordingly. Okay, there we go. So hopefully you're now up to speed on how this works. Again, I stress this is very much beta quality at the moment. It's not set up properly. This isn't the way to set up multi-booting SD cards for the Raspberry Pi. It's just a crude way to test the mechanism to see how it works. But if you're going to go down that road, I do wish you the best of luck. But again, I can't offer any kind of technical support in relation to the actual product in question. If you haven't done so already, please do consider liking and subscribing to us right here on Wi-Fi Sheep. You can find lots of mini-series we have on the channel, including our tiny basic computers and our ever-growing collection of Electronics 010 videos. You can keep up to date with everything that's going on with me and the world of Wi-Fi Sheep by following me on Twitter. It's at Wi-Fi Sheep, that's at Wi-Fi Sheep on Twitter. And of course, your support is always greatly received, and you can get extra content, including a whole playlist with over 30 additional videos, by joining our Patreon. The full details on that are available at patreon.com/Wi-Fi Sheep. As ever, thank you so much for your company, and I hope to see you real soon, right here on the channel. Until next time, bye for now.